Hi, my name is Wang Shen. I'm now doing the homework 3 of probability and stochastic processes. I'm now doing the problem 2. X is uniform in interval of a and b, and y equals to x to the power of 2. And question A, find and draw fx of x and capital Fx of x. Let's first see the question A. Because x is uniform distribution, so Fx of x equals to, when x is between a and b, equals to 1 over b minus a, otherwise is 0. So the picture of Fx of x is this. And capital Fx of x equals to, when x less than a, the Fx of x equal to 0, and when x greater or equal than b equals to 1, and when we can first draw the picture of Fx of x. When x is between a and b, we know that this function, this is the this part is minus a over b minus a equal to, we want to calculate k over 1. So k equals to minus a over b minus a. So this function, we can write this function in this form: 1 over plus k is equals to x minus a over b minus a. So when x is between a and b, Fx of x equals to x minus a over b minus a. So this is question A. And the question B, now given a equals to -1 and b equals to 3, find and draw Fy of y and capital Fy of y, and find mean of y. Let's see question B. First, we know that a equals to -1, b equals to 3, and y equals to x to the power of 2. So we can draw the picture of Fx of x again, this picture. A equals to -1, b equals to 3, And we also can write this picture. Because a equal to 0 and b equal to 3, so this picture take this part from -1 to 3. So when y less than 0 and y the value of y is 9 in this point. And y greater than 9, y equal to 0. When y is between 0 and 1, which is this part, there are two roots, y equals to gx equals to x to the power of 2, and we know that x equal to the square root of y and these two roots. So we can write, so according to the fundamental theorem, we can write fy of y equal to fx of x1 over the absolute value of gx, the derivative of gx1 minus fx this term is 1/4. And we take derivative of this term is take derivative of this term because x equal to the square root of y, so we get this. And when y is between 1 and 9, y equals to, so there is only one root in this function, so we can get fx of x over derivative there is only one root of gx, so we can write the fy of y equals to 1/4 multiply square root of y when y is between 0 and 1. When y is between 1 and 9. Otherwise, this function is 0. So also we can write the capital Fy equal to y 0 when y is less than 0. Y is between 0 and 1. Y is when so we can draw the picture of these two FYY. Y. When y is between 0 and 1, fy is this. When y equals to 1, its function equals to 1/4. And when y is between 1 and 9, when y is equal to 1, this function is 1/8. When y is equals to 9, the result of this function is 1/72. So the picture between 1 and 9 is this. Otherwise is 0. We also can draw the function of capital Y of y. When y less than 0, this function equals to 0. When y is between 0 and 1, this function is this. When y is 1, the result is also 1, or also 1 second. When y is between 1 and 9, the function is this. When y greater than 9, and fyy is 1. So this is the two pictures. And finally, we need to calculate expected value of y, which equals to dy minus equals to integral from 1 to 9 square root of y dy equals to the result is 7/3. So this is question 2 of homework 3.